My name is Dayne Fradejas, and I'll be discussing a certain problem in assignment number 1. So, interest rate and rate of return, problem 1.13. When the inflation rate is expected to be 8% per year, what is the market interest rate likely to be? So, my approach for this certain problem is that the market interest rate usually ranges from 3% to 4% above the expected inflation rate, which there is no exact market interest, so the usual ranges are used to solve this certain problem. And therefore, the market rate is in range from 3% plus 8%, and this 8% is the inflation rate mentioned earlier in the problem. And to 4% plus 8%, and in simplified term, 11% to 12%. Thank you for listening.
Okay, so for this problem, it states that for a company that uses a year as its interest period, determine the net cash flow that will be recorded at the end of the year from the cash flows shown. So first, let's look at what we are trying to find. So it says that we should find the net cash flow at the end of the year, and we are given the receipts and disbursements for each month. So all we have to do is get the cash flow for each month by subtracting the receipts and the disbursements. So the cash flow will be equal to the receipt minus disbursement, because the receipt will be what we call the cash in, while disbursements will be the cash out. For January, it will be 500 minus 300, which will be equivalent to a positive 200 cash flow. For February, it will be 800 minus 500, which will be equal to a positive 300 cash flow, which will give us a total net of 500. So for March, it will be 200 minus 400, which will give us a negative 200 cash flow, resulting in a net cash flow of 300. For April, it will be 120 minus 400, which will be equal to a negative 280 cash flow, which will be equivalent to a 20 cash flow. For May, it will be 600 minus 500, which will be equivalent to a positive 100 cash flow, which will be equivalent to a net cash flow of 120. For June, it will be 900 minus 600, which will be equivalent to a positive 300 cash flow, which will be equivalent to a net cash flow of 420. For July, it will be 800 minus 300, which will be equivalent to a positive 500 monthly cash flow, which will be equivalent to a net cash flow of 920. For August, it will be 700 minus 300, which will be equivalent to a positive 400 monthly cash flow, which will be equivalent to a net cash flow of 1,320. For September, it will be 900 minus 500, which will be equivalent to positive 400 cash flow, which will be equivalent to a net cash flow of 1,720. For October, it will be 500 minus 400, which will be equivalent to a positive 100 cash flow, which will be equivalent to a net cash flow of 1,820. For November, the receipt and the disbursement are equal, so there will be no cash flow for that month. And lastly, for December, it will be 1,800 minus 700, which will be equivalent to a monthly cash flow of 1,100, which will be equivalent to a net cash flow of 2,920. So, by summing up all the cash flows, we will get a net cash flow of 2,920 positive. So, since it is measured in thousands, the final answer will be 2,920,000.
Assignment number 1, Group 1, and I am Garcia, Lemuel, Aldwin from Group 1. Problem number 1.54. The time it would take for a given sum of money to double at 4% per year with simple interest is closest to A. 30 years, B. 25 years, C. 20 years, D. 10 years. Solve this problem. First, we need to list all the given that was stated in the problem. It is said that the future worth is twice the present worth, and the interest rate is 4% per year. The simple interest. Find the number of years. Formulas to be used. Future worth is equal to present worth plus the interest. And the interest is equal to the present worth times the interest rate times the number of years. Um, substituting the value of the interest, we have the future worth as the present worth plus the present worth times interest rate times number of years. Solution. Future substituting the values to the equation, we have F is equal to P plus PIN, then transpose P, we have 2P minus P is equal to P times 0.04 times the number of years. Then cancel P, we'll have 1 is equal to 0.04 n, then n is equal to 1 over 0.04. We have n is equal to 25 years, which is letter B. Therefore, the time it would take for a given sum of money to double at 4% per year simple interest is 25 years.
I'm Gerome Mandapat of Group 1, and this is assignment number 1. I have been tasked to answer 1.35 of assignment number 1. A solid waste disposal company borrowed money at 10% per year interest to purchase new haulers and other equipment needed at the company-owned landfill site. If the company got the loan 2 years ago and paid it off with a single payment of $4,600,000, what was the principal amount P of the loan? So from the question, we can obtain the values for the final amount, which is 46 million, the interest, which is 10%, and the number of years, n, which is 2%. And we have been tasked to look for the principal amount, P. For this question, we can use the formula, the compounding interest formula, which is F is equals to P times 1 plus I raised to n. Since we are looking for the principal amount and not the final amount, we have to manipulate the equation a bit, the formula a bit. So we have to transpose P to the left side of the equation. So we can have the formula P is equals to F over 1 plus I quantity raised to n. Substituting the values that we had obtained earlier, we will have the final equation P is equals to 46 million divided by 1 plus 0.1 squared. And calculating for P, we can obtain the value 38,016,528 and 93 cents, which is the principal amount. I'm Gerome Mandapat, and this is case study for Group 1. This is the background of refrigerator shelves. Large refrigerator manufacturers such as Whirlpool, General Electric, Frigidaire, and others may subcontract to the molding of plastic liners and door panels. One prime national subcontractor is Innovations Plastics. Because of the improvements in mechanical properties, the molded plastic can sustain increased vertical and horizontal loading, thus significantly reducing the need for attached metal anchors for some shelving. However, improved molding equipment is needed to enter this market now. The company president wants our recommendation on whether Innovation should offer new technology to the major manufacturers and an estimate of a necessary capital investment to enter this market. You work as an engineer for Innovations. At this stage, you are not expected to perform a complete engineering economic analysis, for not enough information is available. You are asked to formulate reasonable alternatives, determine what data and estimates are needed for criteria, economic and non-economic, should be utilized to make the final decision. Some information. These are some of information useful this time as follows. The technology and equipment are expected to last about 10 years above new methods are developed. Inflation and income taxes will not be considered in the analysis. The expected returns on capital investments used for the last three new technology projects were compound rates of 15%, 5%, and 18%. The 5% rate was a criterion for enhancing an employee safety system on an existing chemical mixing process. Equity capital financing beyond 5 million is not possible. The amount of debt financing and its costs are unknown. Annual operating costs have been averaging 8% of first costs for major equipment. Increased annual training costs and salary requirements for handling the new plastics and operating new equipment can range from 800,000 to 1.2 million. There are two manufacturers working on the new generation equipment. You label these options as alternatives A and B.
So, hi, my name is Dayne Fradejas, and I'll be discussing an exercise for renewable energy, a case study. So, number one, if you wanted to know more about the new arrangement with the wind farm in South Texas for the additional 60 megawatts per year, what types of questions would you ask of a staff member in your first meeting with him or her? So, my solution for here or my answer is it necessary in that specific town to increase the amount of power per year? Are the wind turbines capable of producing enough power to have an additional 60 megawatts per year? What will be the capital made in 1 year if the power is increased? And what will be the additional cost for annual maintenance, operation, and fuel after a year? That's me. Thank you.
Okay, for case study number 2, the question is, much of the current generation capacity of PEC facilities utilizes coal and natural gas as the primary fuel source. What about the ethical aspects of the government's allowance for these plants to continue polluting the atmosphere with the emissions that may cause health problems for citizens and further the effects of global warming? What types of regulations, if any, should be developed for PEC to follow in the future? Okay, so to answer that, well, factories and plants have always been known to develop emissions that have always been considered as a primary contributor to pollutions. It's indeed true that the government as well as the plant management should always consider the environmental consequences that these bring. Given the fact that these factories and plants are crucial to the function of the industry, it is impossible to simply stop their operation. What we should do is to find convenient ways to maintain the operation of the plant, which also has less detrimental effects to the environment. This may be by lessening the harmful emissions by engineering methods or perhaps simply find ways to produce the same amount with lesser time, which in turn will produce lesser emissions.
Case study 1, problem number 3. You develop an interest in the LEC relation and the publicized cost of electricity of 10.27 centavos per kilowatt hour for this year. You wonder if the addition of 60 megawatts of wind source electricity will make any difference in the LEC value for this next year. You did learn the following. N is equal to 25 years, I is equal to 5% per year, E is equal to 5.052 billion kilowatt hour, and the LEC last year was 10.22 centavos per kilowatt hour. Here in the right side of the slide, we have the formula for the LEC, and N is the expected life of the facility, I is the discount rate, E is amount of electricity generated in year T, where T is equal to 11. From this sketchy data, can you determine the value of unknowns in the LEC relation for this year? Is it possible to determine if the wind farm addition of 60 megawatts makes any difference in the electricity rate charged to customers? If not, what additional information is necessary to determine the LEC with the wind source included? No, the value of the unknowns in the LEC for this year cannot be determined because the annual maintenance and operating cost, the capital investment, and the fuel cost for this year are not given. No, it is not possible to determine if the wind farm would make any difference because the information given is not um, is insufficient. The, the additional information needed are the annual maintenance and operating costs, capital investment, and the fuel cost, so that the LEC for the year when the wind farm is added may be computed. Thank you.